Oh, hey guys, Mr. Trutna. Bye from Mr. Trutna. We are on Unit 3, assignment number 7's notes. If you were not in class, you might want to pause the video at this point and get down what you're looking at. Write that down in your notes. This is the part of the notes that we went over in class, the trig ratios, the finding the missing sides. Okay, so pause the video, copy this down. And we're moving on to working with isosceles right triangles. Okay, so what we have here is, in this particular problem is, we have triangles that are right triangles, but they're also isosceles, okay? So in these problems, we're gonna have a right triangle, and we're gonna have, not only is it going to be a right triangle, but it's going to have two of the sides are going to be equal to each other. All right, like this, maybe 5 and 5. And what we're going to do is we're going to solve for various variables in each one of the problems here. Okay, so we're going to do, let's go ahead and do 1. Let's go ahead and solve for x and y in number 1. And then in number 2, let's go ahead and solve for sorry about that. My chimichangas were ready in my microwave, so I had to go get them. And in number 2, let's go ahead and let's solve for W. W. Okay. All right. So number 1, how do we solve for X? How do we solve for Y? Okay. So just a quick review. Whenever you have an isosceles triangle, that means that two of the sides are going to be equal. And in this case, we have a side that is 5 and another side that is 5. So those two sides are equal to each other right there. So remember the angle, and there's a couple rules about the angles that you need to remember is the angle that where the two equal sides come together, that is what is known as the vertex angle. And this was covered in a previous notes. And then the other two angles, which in this case where the x is and where the y is, those are what are known as the base angles. Okay, now that is very important because it's important that you recognize in an isosceles triangle, and in this case it's a right triangle also, which angle is the vertex angle, which two angles are the base angles. Okay, the base angles are not necessarily the angles on the bottom. Don't make that mistake. The base angles are the two angles that are not the vertex angle. The vertex angle is always the angle where the two equal sides of the isosceles triangle come together. Now, why is that important, you ask me? Well, students, it is important because the rule is about an isosceles triangle, the base angles are equal to each other. Okay? So what this means in example number 1 is that the angle that is x is going to be equal to the angle that is y. All right? And then we also know that the x angle, when I add it with the y angle, those two angles have to add up to be equal to 90 degrees. And that's because if I already have a 90-degree angle, the other two angles have to add up to 90. Okay, so if x is equal to y and x plus y is equal to 90, all I have to do is divide the 90 by 2, and that is 45 degrees, and that is what x is, and that is what y is going to be equal to. So that's how you would go about solving number 1, okay? Let's go to number 2, where we are finding the value of w. Now, there is a very big clue in this problem here, and the clue is with the angle. So if you notice, I have a 90-degree angle, and I have a 45-degree angle. So I'm going to add those two angles up. That tells me that those two angles have to add up to 135 degrees, which means that that angle right there is going to be 180 minus 135, which is 45. So this angle here is 45 degrees, okay? Now that's important because those two angles are both 45 degrees. So that means that those two angles, because they're equal, they are what are known as the base angles of the triangle, which means that that 90-degree angle here, this angle has to be the vertex angle for the triangle. And then remember what I said earlier, recall what I said earlier, the vertex angle is always connected by the two equals, or by two equal sides in a triangle. So those two sides that I'm highlighting in yellow, those two sides have to be equal. Therefore, in this problem, the value of W has to be equal to 9, okay? So we're using the fact we're combining isosceles triangle rules with right triangle rules to help us solve for various values, okay? All right, moving on to the next problem, expected value with a spinner. So remember, whenever we are using a spinner, when we're talking about a spinner, we're always talking about a circle, and the spinner will always be divided up into various sections. In this case, let's go ahead and divide the spinner as such. We're going to divide it up into a section like this, which is 90 degrees. And let's go ahead and say that this section right here, if the spinner lands in that section, you get $6. And then then we have this section over here, which is 135 degrees. If it lands in that section, you get $16. And then if it lands in this other section, you actually are going to lose $8, okay? So what we're going to do is we're going to find the expected value of this spinner. Now remember, the expected value is what you would expect to get on average per spin, okay? And here's how we do it. We're going to do a process, and we are going to repeat the process 3 times, one for each of the sections of the circle, okay? And I'm colorizing the sections so we can refer to them. And here's the process that you do to find the expected value. You take the value of the section. We're going to start in the yellow section, the $6 section. So you take the value of the section and then you multiply it with the fraction of the spinner that that section is. Now, the yellow section is 90 degrees of the circle, okay? And remember, so what that means is that that section is 90 degrees out of 360 degrees, because that is a circle. You reduce that. That tells us that that section is 1/4 of the circle. Okay, so you multiply those two together. It's always the value of the section multiplied with the fraction of the circle that the section is. Okay, so 6 multiplied with 1/4 is 6/4. Okay, so I'm going to write that down. Let's see, I'll write it down over here. So I have 6/4. Then what we do is we're going to add that, and then we repeat the process. So the next section that I'm going to do is I'm going to repeat the exact same process that I did for the blue section. Okay, so if you notice, so what we're going to do is we're going to take the value of the blue section, which is $16, and then we're going to multiply that value with the fraction that that $16 section is of the circle. So you can see that the blue section is 135 degrees out of 360 degrees. And what we do is we reduce that down. Well, 135 over 360, that fraction reduces down to 3/8. Okay, so I'm going to multiply those two together. So when you multiply these two together, you're going to go 16 times 3, which is 48. So this multiplies out to 48 over 8. We're going to add those two together in a second. But we have to do this one more time for the green section. So we're just going to repeat the process. Process is to find the expected value. You take the value of the section. The green is worth, or its value is -$8. And then you're going to multiply that with the fraction that the circle is, or that section is of the circle. Now, what fraction is the green part of the section? Well, there's a couple ways you can do this. If the yellow section is 1/4, which is the same thing as 2/8, and if the blue section is 3/8 of the circle, 3/8 and 2/8 is 5/8. So to make a whole circle, that means the green section also has to be 3/8 of the circle. Notice 3/8 and 3/8 is 6/8. 6/8 and 2/8, which is 1/4, is 8/8. That's the full circle. So that is 3/8 of the circle right there. Okay, multiplying -8 times 3, that gives me -24 over 8. So I'm going to add that to the other two fractions. So I add up 6 over 4 plus 48 over 8 plus -24 over 8. And whatever that equals, that is what my expected value is. Okay. To add these up, I have to have a common denominator. The common denominator of the fractions is going to be 8. And that's pretty nice because two of the fractions already have 8 in the denominator. The -24 over 8 and the 48/8 do. But then the 6 over 4 would change to 12 over 8. Adding these up, 12 plus 48 is 60. 60 plus -24, or that'd be -24, gives me 36 over 8. So that means that, and if I divide that out, I get 4.5. Okay, so I get 4.5. So that is right there, and since we're talking about money here, that is right there, the expected value. Okay, so what this tells me is if the expected value is basically $4.50, 4.5, that tells me each spin on average I could expect to win $4.5. Okay. All right, let's go to the last one, the solving systems of equations using the substitution method. So we're going to be doing systems of equations. Now, whenever you see that phrase, systems of equations, excuse me, all that is saying is that's a way to say that you're going to have two equations in the same problem. So here we have 3x plus 2y is equal to 45. And then we have x is equal to y plus 5, okay? And what we're going to do is notice in this system of equations, that means we have two equations. We have an x and a y. So we need to figure out what is x going to be equal to and what is y going to be equal to, okay? And in this case, we're going to use the fact that x is equal to y plus 5. So what we're going to do is we're going to go up here to this top equation, and we're going to substitute in the place of the x, which is right after the 3. Instead of putting an x there, we're going to substitute a y plus 5. Okay, so this equation right here will become 3, and then in the place of x, we're substituting a y plus 5, because that's what we're told x is equal to. So we're going to have 3 times the quantity, y plus 5, plus 2y is equal to 45. And then what we're going to do is we're going to use this equation right here, and we're going to solve and figure out what's the value of y. So I'm going to distribute the 3. So I get 3y plus 15 plus 2y is equal to 45. My next step in solving this equation would be to combine the 3y with the 2y. So that would give me 5y plus 15 is equal to 45. Then I'm going to subtract 15 from both sides of the equation. That would now give me my new equation after the 15s cancel out, which is 5y is equal to 30. And then I would divide both sides by 5. So I would get y is equal to 6. Okay? So that right there is half of my answer. And the reason why it's half of my answer is because if you notice in the system of equations, there's an x and there's a y. So you have to tell me not only what y equals, which is 6, but you're also going to tell me what x equals. And here's how you do it. Since y is equal to 6, that means I could go up here into this equation, and in the place of y, I could substitute a 6. So this bottom equation would become x is equal to, instead of y, I substitute a 6, 6 plus 5. So x is equal to 11. So solving this system of equations just means you're going to have more than one equation in the same problem. I get x has to be 11 for this, and y has to be 6. Okay? So that would be one example. Here is another example of how we would use what we call the substitution method. Here's another system of equations. Y is equal to 7x minus 8, and y is also equal to 6x plus 14. Okay? So this right here, these two equations are, when you put them together, because they're two equations, it's called a system of equations. Notice each equation has a y in it, it has an x in it. Second equation, y in it, x in it. We have to figure out what is x equal, what is y equal. Okay, now in this equation, if you notice, y is equal to 7x minus 8, but y is also equal to 6x plus 14. So what we're going to do is, in the place of one of the y's, I'm going to substitute in the place of this y, I'm going to put a 6x plus 14. So that gives me the equation 6x plus 14 is going to be equal to 7x minus 8. Essentially what we're saying here is because both the equations are equal to y, it means the equations are equal to themselves. And then I'm going to solve this equation out to find out what my value of x is. Okay? I'm going to subtract 6x's from both sides of the equation. That would cancel out the 6x's on the left. And that would now leave me with the equation of positive 14, I don't have to write the plus, is equal to 7x minus 6x is just x, or 1x, we don't have to write the 1, minus 8. Continuing to solve, I would add 8 to both sides of the equation. I'm solving for x, so I need to get x by itself, eliminate everything, and I just did. I get x is equal to 22. Okay, that right there is half of your answer. I now know what x equals. Okay, so now what I do is, now that I know what x is, and I just figured out that x is equal to 22, I go back up here to either one of these equations, and in the place of x, I put a 22. I substitute a 22 into either equation. I'm going to substitute it into this equation. So when I do that, I get y is equal to, I keep the y, I keep the equal sign, I keep the 6, but in the place of x, I substitute the 22. And then I keep the plus 14. And I work this out to see what y equals. 6 times 22 is 132. 132 plus 14 gives me y is equal to 146. Okay, there we go. X would be 22, y would be 146. That is the notes for Unit 3, assignment number 7.